So thank you very much for the introduction. Thank you very much for the invitation. We are presenting these Lidar-based perception and image fusion systems for spatial applications to introduce a little bit our current work in developing a system, a project in collaboration with LIDAX in order to build a final sensor which is suitable to fly in space. We are progressing in that direction. As you imagine, we started in 2015. We are quite a young company. We are this year making 5 years. And we started working just in LiDAR. We developed a very good, very high quality technology in order to develop LiDAR images of very high quality, which afterwards we've evolved. The starting point was, one second. The starting point was this, okay, right. Sorry. The starting point was this situation, like this kind of imaging, which combined a sensor which was thought for automotive in the beginning and which in fact was licensed to automotive, and which was able to combine being something which is solid state and which at the same time enabled high resolution LiDAR. You know, traditionally LiDARs have 3D layers in vertical, which are quite limited in our case. You may see that this is raw data. This is not accumulated data. This is just what the car is capturing. And this is the very high density image that you can get with the starting point with the LiDAR that we had at the beginning. Out of that, as I was mentioning, we we started working in automotive. And in automotive, we found out a very particular problem they have, which was the fact that when they wanted to manage, of course, with the autonomous car, what they want is to have as much sensors as possible so they can mutually cover the problems that they may have. So if you want to be using 3D information, you can have it in a 2D camera, but if you want to use very high resolution scenes, you need a 2D camera, and then you don't have the 3D information. So you have to combine a lot of sensors. And when they tried to combine the sensor, they found out situations like this one that we are showing here, where they had to do frame by frame a transformation of the data which they have from the 2D scenes to the data in the 3D. You may see that when you manage to match things in the 2D distance, they don't match in the close distance, of course, because there's parallax, because there are different misalignments between the sensors, which can happen after the calibration, because they can have different frame rates, but because a number of issues, they have to manage to do this post-correction, which is a very cumbersome, a very disgusting job to be done. And in the end, what we found out is that the technology that we had enabled us to register very directly, very easily, both the 2D information with the 3D information, with just a very simple adjustment and setup, which doesn't work only for RGB, but for any 2D imaging mode that you want. If you want thermal images, you can. RGB, near-infrared, whre, polarimetric, hyperspectral, neuromorphic, whatever type of camera you may have, which is a projection, can be turned back into a 3D information here. And of course, that's valuable because you got the 2D and the 3D information connected directly, and then you can extract the information from the 2D and then transfer it to the 3D or both, or the other way around, depending on what's the interest that you have when you want to train your algorithms. And well, that's what we managed to do. This is the situation we have. We can have the RGB information, and then we can project all the 3D information onto the 2D information without any problem. And we can do that also in the shape of a video. You can have the video here down in the Vimeo, but here is the video that I wanted to show you, which is the 2D interaction with the 2D projection in real time, again, without any processing, but the projection of one thing over the other to detect how the objects, how the 2D information may be overlapped on the 3D information, and then use that to get the most of the data that you can get. And this is something which is especially relevant, we understand, in robotic applications, because this combination of 2D and 3D information is going to enable you to take both the luminance, both the polarimetric information. If you want to do that With a polarimetric camera and you go to the sea, you can detect objects which are floating. There are a number of things that you can take a look at the applications in our webpage. But here, well, that's the final system that we are going to develop and then we are delivering now, which includes, it's ending its testing. It's going to be available from May, and it's going to have this large spatial resolution of 0.13 degrees, and which is going to be able to work at 10 Hz and 150 by 460 pixels, working in a field of view of 60 by 20 degrees, but that's only the LiDAR, because it includes the LiDAR, and it also includes inside an RGB camera, a thermal camera, and a polarimetric camera, which can be tunable. You can take things in or out as you wish. You can have up to 3 additional imagers. And this is all fitting inside a box, which is just 10 by 17 by 15. So if you want him to walk in the sea, you can use the polarimetric information and combine the 3D with a degree of linear polarization. If you want to detect people in bad weather, you can combine the 3D with the thermal information that you have in the camera. If you got, or any other combination, you can combine 3D and RGB if you're more interested in that thing. So you can choose a little bit what's the best of your system. We can take the data out just with everything computed inside of the system. And then we got also the option to embed some perception inside of the computer that's inside of the unit. Okay, but that was about new space. What's the goal? What's the point of LiDAR and new space? It's something which is going to become more and more growing, we believe, because as long as satellites are going to be smaller, they are likely to need more maintenance. They are going to be removed from the space, from debris. They might become debris that we want to remove. And this means that in all cases, we will have to position and to dock and to place and to orient the satellites in a very careful manner. And if we want to capture them, we have to capture them maybe for just a maintenance service. So you can need to recover them and then get them back in the right position. And that's something that you can better do when you got good 3D information that you can rely on with high spatial resolution. Another very relevant application for LiDARs in space is that as long as more and more families of satellites are going to be there, they are going to need to work in close proximity. So sensors for detecting things which are around them and to fixing the departures from the expected position are also going to be relevant in 3D. And of course, you can imagine that there's all the planetary exploration potential of having an autonomous vehicle which can be supported by a high-resolution LiDAR for path planning, for assessment of the terrain he's around, for detecting obstacles and avoidance as if it was an autonomous car, the same way exactly. And additionally, there's a further application which is mapping the terrain before landing, just to see if the landing is going to be good enough and maybe have some kind of potential maneuver that you can have when you are descending onto the surface. Okay, this was the concept, and that was something that we started to work with Thales Alenia Space in the past. We started developing for them this small LiDAR that you can see above. As long as we have been developing LiDARs for 5 years and several others before, what they asked us is to tune the specifications of the system. So as long as they were in space, they didn't need as much as 10 frames per second frame rate. So we could relax the frame rate and then get a much larger spatial resolution. And you may see that, again, this is one single scene. This is no overlapped points, okay, from our lab, where you could see that, okay, we were having here a spatial resolution of just 0.05 degrees, which meant about 350 points in the vertical layer, which means having a lot of points to have a reliable sensing of the situation. We integrated that for them, we sent that to them, and when they integrated that, we realized that the point was we were not so wrong, because that was the project that Thales Alenia was developing, which is a project named i3DS. And what they did was to develop a kind of high resolution, high complementary sensing system in order to check or in order to dock reliably the satellites. And as you may see, they are using cameras of different types, plus the 3D system, which was our camera, which you may see it's here, okay? They use them in order to dock the satellite with more precision. They were testing that. They are continued working on that. And that's another point of view. They won a project. They won the Toile de l'Europe award. And well, we've been collaborating with them, and we still keep a good relationship with them. And we were, they told us it would be a good idea to try to explore a high space LiDAR. So we came to one SECPHO meeting on space some years ago, and there we met LIDAX. And with LIDAX, we started developing together a potential further project, which now is a reality, which now we have just started, which is a project which is named Development of an Imaging LiDAR for Space Application, which is this code, which is a collaborative project with LiDARs we are currently developing, which is financed by the European Space Agency and CDTI. From our contacts with the European Space Agency, it looks like there's a gap for these medium-range LiDARs. For this type of application that we have, there's not a full solution which is currently operative. So we are going to work in this project in order to first start with the mechanical and environmental testing of a space LiDAR, which is based in our concept, with a preliminary focus on managing vibration and thermal management for the components that we still have. And as long as we are just in the spec part of the project, we are just interviewing now end users for potential spec definitions. So in case you were interested in giving us your feedback or your input on which type of specifications you feel would be better for this type of LiDAR, we could try to orient that in that direction along the project. So it's a moment for having a kind of common ideas on which is the right approach for making a good mid-range space LiDAR. And that's where we are. So as a wrap-up, just to comment that in our view, there's a large number of new space applications for this type of solid-state medium-range LiDARs, like the ones we are presenting here. That image fusion is going to play a role because in the end, we are finding more and more that people don't want to deal with three types of customers, two types of providers for getting the camera, for getting the LiDAR, for getting the other type of camera. So making this kind of experience integration work that we already do is something which is also giving us very good results currently. And of course, there's a lot of new space applications for these LiDARs. We are now working in mechanics and thermal. We have a number of degrees of freedom for customization. Always, everything comes with a price. If you want more resolution, you will not have as much frame rate, but the other way around, so we can manage to have more field of view, more range, less range, more eye safety, less eye safety. We can play with it. And we can add point cloud management, perception, and data fusion, which are perfectly valid in all senses in space. It has to be, once you train the AI, of course, training the algorithm is possibly the tricky part that we have to manage if we go to that point. But data fusion has no issue in order to get to space. And as Beamagine currently, both in space, but also in defense, we are having a lot of activity now, both developing this off-the-shelf product we develop with up to 13 imaging modes, which can be customizable. We can build fully customized sensors based on any spec. We discussed that. We are working also in integration services of perception units. We can include embedded fusion, embedded computing, deep learning, whatever. And we have now experience within automotive. So just, I finished that way, keep hearing of your interest. And just contact if you have any details. Here you have the contact. Also, you can visit our webpage where you can have more videos on different applications like the ones I've been collecting. Thank you.
Okay, thank you very much, Santi, and congratulations for the evolution of your systems, the system that you are launching in May. Congratulations for the reduction of size, the evolution of the specs, a lot of things in a short period. I think it's a great effort of all the team. We have the first question from Juan Pastor, from Indra. He says, dear Santiago, the aiming system is based on mechanical pointing, or do you have experience on laser beamforming? Thank you.
We have some experience in laser beamforming, but I don't get what do you mean by the pointing system? Well,
He says
it's a kind of a camera. The system works as if it was a camera with the 3D and the 2D at the same time.
Maybe Juan, you can unmute your micro and you make it the question directly.
Okay, thank you very much, Santiago. Yes, when I'm talking about the pointing or the aiming, I'm thinking about, when I imagine a LiDAR, I imagine a mission system which requires some kind of pointing capability, and then the detection system. So yeah. I read in some place that you have separated the detection and the emission physically. So you have some kind of issues that you have to manage, and you were able to manage. But I don't know if this laser emission, it's based on some kind of optical mechanical pointing system, or is it based on laser beamforming?
No, it's a discussion in what's mechanical and when do you end the mechanics. What we are doing, we use a scanner in the end. It's not a mechanical scanner. It's a MEMS mirror, essentially. It's a 2 millimeter MEMS mirror, which is oscillating. And then we have proprietary part in our system, which is in the detection, and which is used for improving the performance and being quite immune to background noise. So that are the 2 points. We are scanning with a MEMS mirror, but then when we scan back when we receive the system in a separate path, as you say, we have a trick in order to remove the background light so we can work in very sunny environments.
Okay. So thank you very much. Maybe I will contact you again for maybe a future contact, I don't know.
It will be a pleasure, of course.
Okay, thank you.
Okay, thank you, Juan. Any other question from the audience? Well, Santiago was saying that he's looking for end users to define for the definition of new specs. Enrico, do you know end users that can help?
I'm sorry, I'm always interrupting. No, first of all, Santiago, very good work. Congratulations. As a matter of fact, I'm working at the moment in a couple of projects which are very much of, which overlap with what you're doing now, and it would be very interesting if we could discuss offline on this. Yeah, we have actually a couple of papers at IXO, the end of March. I don't know if anybody will be attending at the IXO conference, Space Optics conference. But yes, I'm working on advanced imaging LiDAR system, and also for wind, and also for navigation. I mean, what you said is what we are doing now. I'm doing now, and it would be very interesting if we could maybe have a talk offline for provide the input on requirement, but also for potential cooperation for the future. Because it's an area which very much I'm working on this.
Okay, if you want, if you could send your email by email or something like that, it will be a pleasure to have.
I will like that. The work you referred to, this is a contract. This is a TRP GSTP activity?
I think it is. It's a GSTP make, I think.
Oh, okay, GSTP, okay. Oh, GSTP make, okay. That's it, yeah. Okay, thank you. I'll contact you, Santiago.
Thank you very much. It will be a pleasure.
Okay, thank you, Rico. Any other question for Santiago? No. Okay, thank you. Thank you very much, Santi.
Thank you.
And well, that's it for today.